One of the keys to creating successful lighting is to learn how to modulate the intensity of the light. You've already seen how you can set the light intensity globally by setting the value of the color and by boosting it with the multiplier or by dimming it with the multiplier. But this is a kind of top level or global control over lighting. In the case of spotlights and direct lights, you've seen how you can modulate the hot spot and the fall off, and that goes a long way into creating realistic lighting, because we can vary the intensity within the cone from the center of the cone outward. However, it's also possible to vary the light intensity as a function of distance away from the source. This is called decay or attenuation. The default behavior of lights is actually to remain at full intensity no matter how far away you are from the light source. Take this OmniLight for example. If I were to construct a room that was 1 mile away from this OmniLight, it would still be lit with full intensity. And this is just not very realistic. In the real world, the light energy will decay over distance. And you can set that behavior up right here. The default, as I said, was not to have any decay, but you can set that to decay with the inverse of distance, or more quickly, with the inverse square of distance. And in the real world, this is how light decays, with the inverse square of distance. You can see that it's a little bit dimmer in the viewport than just inverse is. This sphere surrounding the OmniLight represents the full intensity of the light. So the light is at full brightness within that sphere, and then as it starts to go beyond that sphere, it will start to decay. You can set the size of that sphere right here. I'll make a test rendering. It should be quite a bit dimmer than our original rendering because the light has been set to decay the further away it is from the source. Now this is kind of a simple-minded way of controlling intensity over distance. It merely decays the further away that you get. That may be physically accurate, but it's not flexible enough for our needs. Therefore, you can use the attenuation system as an alternative to using decay. And there are two parts to attenuation, as you can see. There's near attenuation and far attenuation. I'll start with far attenuation. I'll use it, and when I check that, we see another sphere. This sphere represents the boundary where the light will start to attenuate or decay, that is. So, in other words, the light is at full intensity within that sphere, and then it will start to decay or attenuate as the light rays go beyond that. So let me adjust the size. Notice that there are two spheres. There's a start sphere here and an end sphere out here. And this works a lot like hot spot and fall off do in a spotlight or a direct light. So the light is at full intensity within this sphere, and then it falls off to zero intensity at this point. So if I wanted this light to illuminate the sofa, say, but not this cabinet at all, I could set up attenuation like that. Now let's make another test rendering. Because I brought the start and end spheres close together, we're getting very dramatic results here. Think of it a lot like a spotlight. If we make the end much further away, then we'll have a greater distance for that light intensity to fall off. And the rendering will look a little bit more subtle. Now, near attenuation is the same idea, but it means that the light intensity will ramp up and it will start illuminating when it gets to the start area here. I'm going to increase this so we can see it in the viewport. So this has no physical basis in reality, because lights in the real world just don't work this way. What this is saying is that there will be no light within this inner sphere, and then it will ramp up and get up to full intensity out here. And then it will continue on at full intensity forever. So you can use near attenuation if you don't want to illuminate something that's close to the light source. You can use near and far together to create a series of gradients of light. So we're going to get no light, we're going to ramp up, we're going to have full intensity here, and then we're going to ramp down again. So you really have incredible control over the light in the way that it falls off or ramps up over distance. You can also scale the light gizmo non-uniformly to create an elliptical or oval-shaped illumination. And this can be useful in certain situations. Maybe I'll flatten it out as well. So you can shape the light and control its intensity over distance. This gives us really a lot of power over controlling where that light is going to be bright, how it's going to fade in, how it's going to fade out. And so you really need to master these qualities in order to really paint with light and illuminate your scene exactly as you imagine.